2.
Okay, I think we're going to start. It's 2:30 right now. Can you hear me properly? Can you hear me, all of you? Great. Okay. So, I would like to welcome all of you for the presentation of our FP7 research project called InTime. We will be here presenting the project for around 1.5 hours. Basically, give you a short introduction what the project was about, what have been the challenges we are trying to focus on, what are the main results, how can we help the European machinery industry to improve the performance. We will have some videos describing the tools we have generated in the project. Then we will have a use case presentation how the tools are being applied into the industry and pilot cases. Louder, okay. And then in the end we will show you the current tool that we have developed. So we will go online with the tool and show you how the tool is working, how the tool is supporting people from machinery industry, especially in decision making better decisions and in improving in delivery reliability. So the project is called InTime, so I guess you can think that it has something to do with time, it has something to do with delivery reliability. We are focusing on delivery reliability as this is nowadays the most important success factor of companies, right? It's not, it used to be flexibility, it used to be quality, it used to be lead time, right? But nowadays, all the other key figures are expected to be there anyways. People or customers are looking for delivery reliability. Why is it that important? Because if you're reliable, it means that your processes are reliable. If you have a short cycle time, nice, but if you can't meet the delivery date, you don't have reliable processes. And me as a customer would not trust you, right? So what we are trying to improve is delivery reliability, and these are some findings of a study we have done where we asked companies which measures they're focusing on, and you clearly can see that it's delivery reliability. And why is this so? What we have done was another study where we have been trying to find the correlation between, in this case, the capacity utilization and profitability, so success of a company. And an interesting finding was that that no matter how good you utilize your capacity, how good you make use of your resources, the profitability remains the same, right? You see, if you have utilization of below 80%, you have in the year 2005 a profitability of 5.7. Utilization between 80 and 94, you still have more or less the same profitability. Utilization of up to 100% is still the same profitability, which means it doesn't matter how good you exploit your resources, it has no influence on your profitability. But in case of delivery reliability, if you have a bad delivery reliability, your profitability is definitely not as high as when you improve your delivery reliability. Which means that there is a huge correlation between delivery reliability and the success of your company. So these are pretty impressive findings. That was one of the reasons why we wanted to focus especially on delivery reliability. And our sector where we did this was the machinery industry, because especially machinery industry, which is basically described by pretty complex products which consist of thousands of active parts that have to be purchased, and you also have a very high level of customization. So especially in this sector, companies really do bad in terms of delivery reliability. Just 2 slides of how the project was set up. We had partners from 3 different European countries, from Italy, from Spain, from Germany. We had, first of all, we had research partners like myself coming from the University of Aachen. We had partners from the University of Polytechnico di Milano here from Milan. We had research partners from Spain, from IDECO. Then we had associations like Uchimo in Italy, like the AFM in Spain, like the DIN in Germany, and we had pilot companies where our solutions have been tried out, tested, evaluated, and redesigned and tested again. We had 3 different pilots. We had Fidia, that's a producer of numeric controls in Italy. It's located, the headquarters is located in Torino. We had Danobat, a Spanish machine tool producer, and we had Otto Juncker, which was a producer of Führnensis, located in Germany. The project itself took 3 years, consisted basically of 4 phases, analysis phases, concept design, development phases, where all the concepts, the framework that we have defined has been implemented into an IT tool, and then we had the pilot implementation where we tried out all our solutions, and we run through this cycle 2 times. As we had our first findings in the pilot implementation, we went into the analysis phases again, had some adjustments in the concept, had some adjustments in the development, and went into the pilot implementation again. So that was the basic setup of the project. As you can see at the project plan that we are ending, basically we're having our final review meeting today. The project was just half an hour regarded as positive, so we're pretty happy with the results. So let me explain you right now in the next slides what we have done, and especially what we have been focusing on. I mentioned before that we have been focusing on delivery reliability because this is one of the biggest issues in machinery industry. Just some numbers. How does a typical machinery industry company looks like? Usually it's the typical SME with around 100 to 300 employees, a turnover of around 50 million euros, has the big part of the turnover is accounting and the working in progress. We have many suppliers, many different suppliers. I'm going to come back to this later on. We have many active parts. This 3000 is actually a little bit misleading. 3000 is a small machine, or rather a component supplier. But if you have big machines, you go up to 16,000, 17,000 for a machine tool, for example. And if you're talking about a plant, you have 100, 200, 300,000 active parts that you have to be able to manage, that you have to be able to supply, that you have to be able to assemble, right? So that's basically the environment that we are moving in. So how does the supply chain look like in the machinery industry? On this slide you see the comparison of a typical linear supply chain which you find, for example, in automotive industry, which you find in consumer goods industry, with the typical characteristic that the OEM is the big player, right? It's the big firm, the big company with market power. Take a L'Oreal, take a Bayersdorf in consumer goods industry, big market power. Take a BMW, Mercedes, whatever. They are the big powers. They have a very linear supply chain, which is very stable in time. So usually they do not exchange suppliers that often. They have long-term relationships with the suppliers. They have a high level of transparency. They announce their forecast, their production forecast, up to all levels of the supply chain. So even the last part of the supply chain knows what the first part is producing, right? So this is a typical linear supply chain, and usually they do not have big issues with delivery reliability because of this high transparency of good forecasts. So they know what to produce and they are able to provide it in time. But on the other side, you see a typical environment of a company in machinery industry. And there are huge differences. First of all, we have something which is called non-hierarchical production network. We do not have stable relationships in terms of time, because we have such a high level of customization. That means in one project you need supplier A, another project you need supplier B, maybe another one again supplier A or supplier Y. So for each project the entire scenario can change, right? So you do not have this long, stable relationship where you build on trust, where you build on transparency, where you have stable forecasts you can share among each others. Not at all. Another big issue is the market power. As in the linear supply chains, the market power is usually at the OEM. In machinery industry, the market power is at the suppliers. The big companies are somewhere in the middle, like you can see around there. It's the Siemens, it's the Bosch, it's the Festool supplying, for example, engines, gears, bearings, numerical controls, and these are the big companies. And if they are supplying too late and you are the small SME machine builder, you don't have much influence on that, right? So this is one of the reasons why the delivery reliability is that poor. So if we zoom in such a relationship, I want to play through an order fulfillment process with you right now. We have the final customer that is ordering machine tool. He's ordering it at my side. Everything that I cannot produce due to technical reasons, due to capacity reasons, I'm gonna source it to my suppliers. So they hopefully supply on time. I'm gonna do the final steps of assembly, for example, as vertical integration is shrinking with the time. And then I hopefully supply to my final customer on time. But if you regard the statistics in machinery industry, you find numbers like delivery reliability of 50, 60, 70%, so not really reliable. I even have had many projects at companies from industry, from machinery industry, where the delivery reliability was below 10%, even though some of them had a pretty stable forecast. So they really have difficulties in performing well. And now we're asking ourselves, why is this the case, right? So what are we doing? We are analyzing the final step of production, the assembly. If you go into the assembly, you realize that missing parts are the biggest issues for the company. The worker is trying to build in the bearing, the screw, the engine, whatever, but he finds out that the part is not there, right? He just finds out when the part is needed. What happens? He is running around, he's panicking, running around on the shop floor, looking for the part, talking to his guy from the storage, talking to his purchaser, and then suddenly they find out that the part is somewhere still at the supplier's side, right? So what do? They get themselves a car, go to the suppliers, pick up the part by themselves, and try to build it in still in time, not facing any penalties from the final customer, because the final customer wants his part, his machine being on time. If we ask ourselves why these missing parts are occurring, in 50% of the cases it's because our suppliers are late, like I mentioned. So our idea of improving our delivery reliability, the delivery reliability of the OEM, is to focus on a big portion of the cake in improving suppliers, improving the delivery reliability of suppliers, and thus making this piece of cake smaller, thus minimizing the number of missing parts in assembly, which then again gives us the better delivery reliability. So how are we doing this? We have basically two major concepts in our projects that we have developed. First of all, we have a platform which is called My-Factory, where all orders are running through, right? My-Factory is a platform which connects different ERP systems so that the order fulfillment can run through smoothly. We are gathering all the data from any order fulfillment process and are able to analyze it. We can analyze the delivery reliability of all the companies that are on the platform, which gives us a big advantage, as for example, I can see how good the company performs with me, how good the supplier performs with me, and how good the supplier performs with someone else, right? Because you always have different constellations of supplier customer. You might be a customer, but you also might be a B customer or a C customer of a certain supplier, right? So in some cases, it might happen that the supplier performs not very well with you, but very well with others. If you see that, it qualifies him that potentially he's able to perform, but for any reasons he is not doing it for you, right? So that's what you are able to find out. We call this the external transparency tool. How the tool looks like, we're going to show it to you later on. We're going to show you the tool in a live demo after that. Then we have the internal transparency tool. I mentioned just what happens if a part is late. The worker is running around looking for the part, which means the assembly stops, which means we have efficiency losses, which means we have additional coordination costs because the guy is running around. We have additional costs because we have to call the supplier all the time. Well, where are you? Where are your parts? So the purchasing department cannot fulfill their job. We need more capacity over there. Maybe we have to go to our supplier by ourselves, which gives another cost factor, which means you have many different cost factors which come with belated deliveries. And in worst case, you have the penalties from your customer if you cannot keep your delivery promise. So what we do with this internal transparency tool is we are estimating the costs that occur if a part is too late, right? We do it in advance, not afterwards, because we are able to estimate this cost in advance. That we know if the supplier does not perform well, we will be facing these costs. And our idea now is to incentivize this customer. We want to incentivize the customer. We want to pay a little bit more to make sure that this customer prioritizes me in his production schedule instead of my competitor who is fighting for the same capacities of the supplier. So we want to pay a little bit more because we know that we will lose, let's say in a project, 10% of the project volume if the supplier is late. So we take 1% of the project volume to incentivize the customer, the supplier, to try to make him be on time, which allows us to be on time as well and still be profitable. Because otherwise we would lose those 10%, and if we have a margin of, I don't know, 5, 6, 7% only, we have a negative business, right? So that's the idea. If you talk with people from the purchasing office, they will tell you, I will never pay more. Why should I do that? Never. My goal is to get low prices from my suppliers. But you know what? This guy does not care about what is happening behind him. He does not care if the guys in assembly have no parts to assemble. He doesn't matter for him. The performance of the own company, he doesn't care because he is incentivized by minimizing the supplier's prices. But then you have to see the entire chain, right? Under the bottom line, we want to have a positive business, which means we have to talk not to the purchaser, but to the one who is responsible for the entire budget. And then he realizes, okay, I pay a little bit more, but in the end, the probability that my supplier is late, that I am late, is much lower than it is without incentivization, right? So this is the transparency tool. This is the incentive system, we call it, to incentivize the suppliers, hopefully improving the performance. And what gives us this thing? I mentioned before that in the machinery industry we have the non-hierarchical production networks, we have no transparency. But right now, with this approach, we are kind of gaining transparency indirectly, because we're saying that the one who really needs the parts really urgent, is willing to pay more than someone who needs the part 2 weeks later than him, right? So the value or the height of the incentive is an indirect criteria for the urgency of the part, which is giving us a kind of transparency over the demand situation in a non-hierarchical production network. So how do the tools look like? Like I mentioned before, I'm just going to go through this briefly right now because we're going to jump into the tool later on. We're going to have 2 videos as well showing you how the tools work. So basically we have such a kind of dashboard where you can see the performance of the supplier within the past. You can see it with you can see the performance with others. You can see different other criteria like lead time, but the most important one for us is delivery reliability. When you go through the order fulfillment process, and if if you're sending your queries to different suppliers, asking them for offers, right? So you're asking for offers from different suppliers. You are able to compare the offers. Let's say maybe one supplier offers you this bearing for 250 euros, but you directly see the delivery reliability. Maybe it's very bad. Then there is another supplier, maybe supplying the same bearing but for 300 euros, but his delivery reliability is much better. So you might, together with the information how much it would cost you when the part is late, you might pick the more expensive one because it's more reliable, right? So the tool gives you the chance to compare the different suppliers, compare the performances, compare the prices, the offers basically. We're going to show you this later on in the live demo. And then we have the other tool for the internal transparency, where you have to put in all your financial data of your company, like costs for labor, costs for certain activities, for transportation, whatever data you need to calculate all those costs, we are mapping within the tool, and it gives you then all the calculations, and finally giving you the costs if the supplier is late, which we call the value of an InTime delivery, like the other way around, right? So that is the basic idea of our project, what we have developed, what we have tried out at our pilot companies, successfully tried out, that we want to present you right now in a little bit more detailed level. Do you have questions so far to the overall concept? Are there any questions? No questions over there? How come? Okay, then we will jump to the two videos. We start with the internal transparency tool. There is a narrator already, so it will be a safe plate video where the narrator is telling you what is happening. The second video about the external transparency tool, my colleague David will present to you. He will have some few words, comments on that, because there is no narrator yet on the video. Okay.
Hello and welcome to the presentation of the InTime's internal transparency tool. This tool trains in the InTime project, which is set in the 7th European Work Bank. It has been developed as an answer to the gap detected on the logistical process of non-hierarchical manufacturing network. One of the main problems related to logistic processes of the complex non-hierarchical manufacturing network are the losses in competitiveness due to belated deliveries of suppliers that can even stop production systems and so create a huge damage on the company's income statements. In order to solve this problem, a consortium of 12 participants composed by technological centers, universities, and well-known enterprises from 3 different countries of the European Union was created and worked on the development of efficient models and tools that could help to improve suppliers' delivery reliability. As a result of those developments, the internal transparency tool was created. Internal transparency tool is a cost estimation tool that will help enterprises to calculate the impact cost due to the early or delayed supplier deliveries within their industrial activities. The internal transparency tool is presented in an Excel file composed by 7 main worksheets that we are going to visit step by step. In this moment, we are on the general menu worksheet, which gives access to the rest of worksheets. As you can see, they are divided into 2 main groups. Financial data, delivery data, and cost calculation worksheets make part of the input data that will be provided by the user. On the other hand, delivery performance and cost impact worksheets will offer the output data that will help the user to make more accurate decisions related to suppliers. As we have already seen the main menu, we will start visiting the different worksheets to understand how to manage these tools. The first step to be given is to fulfill financial data worksheet, because data given here will be used for different calculations of process. On this sheet, the user has to introduce financial and cost information, as well as some information regarding business volume and other management process. This information has to be given considering the company variables, the procurement, project management, production, the transportation, the customer claims or penalties, and the inventory. These variables will be introduced in the cost expression to calculate the impact of non-time deliveries that will be developed on the cost calculation worksheet. When every white box of active column has been completed, go back to menu button and choose Delivery Data Worksheet. On this sheet, the user has to provide delivery data regarding a particular supplier or a particular manufactured part. You will have to introduce the class code, the supplier, the purchase price, the inquiry date, the planned delivery or reception date, and the real delivery date of each of the order positions up to a maximum of 1,000 order lines. Next step is to visit cost calculation worksheet. Even if it is classified in the input data worksheet group, normally no changes are needed on this worksheet. Nevertheless, the sheet offers the possibility to modify the cost drivers and expressions, although the introduced array formulas make it a bit difficult to manage if at least medium Excel skills are not achieved. Hello and welcome to the presentation of the InTime's internal transparency tool. This tool frames into the InTime project which is set in the 7th European Supplier Delivery Reliability has been developed as an answer to the gap detected in the logistical process of non-hierarchical manufacturing using several indicators to describe one of the main problems related to logistic processes of the complex hierarchical manufacturing network are the lost cost impact worksheet is divided in the calculation of points on the graph that only cells with data are selected in order to show the correct graph. As this Excel tool is prepared for the calculation of up to 1,000 order lines, the user should update the filter as explained in the text and selecting empty cells in the filter. A direct link to the filter is provided. Once in the reliability of our suppliers, we're going to see the impact in costs that their delivery behavior makes in our income statement. The cost impact worksheet is divided in 3 main sections. The first section shows the distribution of the additional costs incurred by belated deliveries attending to the different sub-processes of the order management process. The methodology to obtain these costs has been the process-based costing. Depending on the financial, cost, and organizational parameters of the company, the distribution of the additional costs attending to the sub-process may vary significantly. For example, an influencing factor could be the application of penalties to the suppliers or the impact of a delayed delivery in the assembly of the whole project. The distribution of these costs is offered both in tabular and graphical ways. The second section of the worksheet shows some statistical information of these additional costs. Apart from standard indicators, the user may gather information of the distribution of the incurred additional costs, introducing a lower and upper limit, so the percentage of the order lines within this range is calculated. Finally, the quartiles of this additional cost distribution are provided. The third section offers visual information of the distribution of the additional costs attending to the deviation from the expected delivery date. As in the previous delivery reliability graph, the user should update the intended filter using the provided link in order to unselect empty cells. Otherwise, Excel will not show the correct graph. The last worksheet to be visited in case of doubts is the variable description worksheet, which is neither in the input or output data groups. It is just a worksheet where different variables used in the tool are explained and their units are given. All worksheets have already been explained, and as you can see, Internal Transparency Tool is an easy managing Excel file which can help you to evaluate your supplier reliability and estimate the cost of their delivery failures, giving a clear view in the impact that this may cause in your income statement. We hope the video has been useful enough for a better comprehension of the tool. Thanks for watching.
So maybe to make it a little bit clearer to you.
The second section of the worksheet to obtain these costs and organization and influence the indicators they use can lead the board attending to the deviation from the expected.
This is what you get out, right? This is basically the final cost curve, which consists of different other cost curves because of coordination costs because of penalties, cost of additional transportation, for example. If you want to meet the delivery date at your customers, because you were too late, but you still have some time for delivery, you might choose an alternative delivery route, right? Instead of sea freight, you go for air freight, which is much more expensive. So all these cost curves are summed up to this one cost curves. On the x-axis, you have the dates of delay of the supplier, and this is the cost impact, right? So you can estimate if the supplier is late 10 days, it costs me around 1,000 euro in this case for this part at one of the pilots. In case of he's 20 days later, 30 days, it's even higher. It goes up to 5,000, 6,000 euros, right? So this basically gives you the margin which you can make use as an incentive for your supplier, hoping that he will perform better. So right now we will jump into the second tool, which is an IT-based tool based on this B2B platform I was talking about called BI-MU.mpeg, which is linking ERP systems with each other. So we use this platform to put our results on and extended this platform, so to say, with all those visualization of the performance of the suppliers. So my colleague David will explain the tool to you while the video is running.
Thanks, Thomas. So at first, we just have a short motivation for this tool. It's basically that we support the ordering or the procurement process with additional information. Okay. Okay. This is basically the central hub, the BI-MU.mpeg. All order data is communicated about, and here, this is a tool we collect the data we use for our analysis. So and then for this video we set up a demo scenario which uses the example of one company, it's Machinery Inc. This serves as a use case for our video. So we want to order a cooling aggregate, looking at the procurement process, and here's Anna, our procurement manager, and she wants now to order this cooling aggregate. So the default process would be she had to use the telephone a lot, call people, enter the data into the ERP system, and then perhaps faxing the request for quote and getting back the quotes. With the new process supported by InTime, Anna is now able to use the BI-MU.mpeg platform for the EDI, so having electronic order processes. And this is now, we're logging into the platform. And we see there's the InTime functionality. This is what we added mainly in the project. This is the external transparency tool. And first, she takes a look at her complete supplier base using the overview dashboard to analyze her suppliers in detail. But now, to begin with the procurement process, she knows which part she wants to procure. This is the cooling aggregate. She can use the performance dashboard to select suppliers for sending a request for quotations. So she can select the product. And then she's able to select the analysis time frame. And now what she gets is first a lead time breakdown for all available suppliers for this product, and on the other hand the previous orders she had with these suppliers. So now she can use this analysis to select a few suppliers for sending a request for quotation. And this is now how she creates such a request for quotation in BI-MU.mpeg. This is the web cockpit, so you can basically think of it as an addition similar to ERP system. You have to fill your fields, and then after you're finished, you can send the request for quotation and your supplier receives it via EDI. So now she would do this for the 2 other suppliers, and then she waits for receiving the quotations from these suppliers. When all quotations are in, she normally wants to compare these quotes, and there we have another dashboard where she will be supported in selecting the right supplier for the order. And this is done, you can see, on the basis of just the data for the quotation, so delivery date, price, and so on. But also, as you can see in the red and blue curves, this shows the delivery reliability of these suppliers. So she can directly compare the delivery reliability. The red curve is delivery reliability with her company, and the blue curve with the network. And then, after she decided for one supplier, she can use the negotiation dashboard to really do a detailed analysis on this supplier. For example, to support her in negotiating a contract or ordering contract. So here we see the supplier is in general very reliable, with a lead time of about 50 days for this product. And you see there's no big deviation, it's pretty stable. And in the KPI breakdown, you will see that all KPIs are in the green range besides one. And this is delivery lateness. This means if this supplier delivers late, it's more than branch average. So she will address this in negotiating the ordering contract, and there's more information, more pressure to use on the supplier. And after she has all the information, she can send the order. And basically, again, to summarize everything, the procurement manager is supported by a lot of additional information he would normally not get. And the dashboards are embedded into the BI-MU.mpeg platform, which makes a nice user interface. And basically that's it. And I think we will now later, we show the dashboard live.
Thank you very much, David. So let me quickly jump into the presentation again. Okay, so these have been the 2 videos. Do you have questions so far? Just later on we're going to jump into the tool, right? So we have 2 more short presentations. First of all, a presentation about what is called a CWA. Within the project, we had to create a standard, which nowadays became a European-wide standard, especially in EDI, which means an electronic data interchange, right? Because if you want to do all the analysis, you have to make sure that data is always the same. We need a standard for that. Otherwise, you will never be able to assess data automatically in a proper way. So that's why we have created a standard, which has been revised and became a European-wide standard nowadays, which is public and can be used by any companies using ERP systems or cockpits like it was presented right now. So there will be a short presentation on the CWA, what it was about and what exactly it brings us. Jürgen?
Hello everybody. So, as Thomas told you, we have standardized this approach because it's a network approach. So it's merely required that we have a kind of open specification, other platforms might follow and the users may rely on. So it's just not one platform that uses one kind of standard, self-defined standard, but there may be other platforms too following this standard. And within this standard we rely on the EDI principle, which enables to use compliant communication, and the new part of this standard is the multilateral nature of this communication. In classical EDI, you got bilateral agreement with each of your partners and suppliers to use EDI. We have done a new approach which uses one agreement for a central EDI hub, and so you have an EDI connection to the whole community, to the whole production network. So, as you have seen before, we have relied on a platform called My-Open-Factory within the project, and this is based on a secure connection due to the hub of each partner to the hub. So security, authenticity and integrity of messages in the first and the last mile is assured. And the data format has been specified within the CWA 16504. Additionally, there is added a long-term storage as a service to this platform to keep the messages intact and their integrity for the required retention period. So this standard is open to be rebuilt by other platforms, not only by My-Open-Factory, and it's published since September this year.
Okay, thank you very much. What you will see right now is, I told you that we had 3 pilot companies in the project, which basically were the basis for us to play with them, to play with our tool, to try it out, to see if it's really bringing some benefits to them. And we picked one, Danobat, the producer of machine tools, where we applied the tools and how the entire new authoring process with our supportive tools looks like will be presented now by our guides.
Thank you, Thomas. Okay, as you know, we have had 3 industrial companies in this project involved, representing 3 different steps that we can find in the non-hierarchical production networks. From the idea that they are used to produce CNC components, then Danobat, machine tool manufacturer, and then Otto Juncker as a peer standard industrial machines producer. We will show you the use case that we carried out in Danobat. First of all, I must tell that initially, instead of Danobat was Starta involved in the project. Starta is a machine tool manufacturer specialized in centerless grinding machines. Machines that usually this environment is used to turnkey projects, make to order production type, small medium cylindrical parts. They produce small medium cylindrical parts machining in large production batches, and the catalog they have is based on 6 different machine models with more than 15 units produced per year and with a turnover around 5 million euros. But as I have told you before, in March of 2011, Startup merges into Danobat, so Danobat was who assumes all the activities depending in the project. A short introduction about Danobat. Danobat is divided in 4 divisions: sewing and drilling division, turning division, grinding division, and composite division. And the use case has been centered in grinding division, where is Startup. Something a little bit more about Danobat Group. They are composed by these companies: Danobat, Suraluce, Danorail, and DRS, Goiti, and Goimet, with a turnover of 190 million euros in 2010, and with more than 1,000 people working there. And they are in 40 countries in 5 continents. A little bit more about the product that they produce. These machines are machines with high complexity, composed by approximately 12 functional modules and around 1,000 active parts. Generally, the base machine is standard, but then depending on its customer, what kind of product must be mechanized, it must be customized. And also, sometimes they need some handling systems to introduce and take out the parts. The main parts of these machines are the base or the bed, the grinding wheels, regulating wheel stocks, the cover or the closure, and the CNC. And as I have said, the handling system is it has big personalization or high customization due to the dependence on the customer's internal needs. Regarding the purchase departments and how they purchase, we have to say that the 80% of the purchase volume is obtained with 30 suppliers, when they have around 163 suppliers in total. And the main suppliers are machine and part suppliers, electrical and electronic components parts, and transmissions and engineering suppliers. Regarding where they buy this part, the 66% suppliers are national, 19% European, 4% Star Community, and 1% from Danawat, because it has its own company, Goimet, which mechanize the most important parts of the machine. The beds and the strategical parts of the machines are mechanized into Danawat. And the purchasing politics that they follow, they are we can sum in long-term relationships, minimization in number of suppliers, and in continuous improvements. They try to work every day with their suppliers in order to improve the delivery reliability and all the aspects that permit to their suppliers and to them to make the best business. Regarding what kind of problems they found into their supply chain, the main problems are the long time from the quotation request to the order sending, lack information about suppliers' real status, about the capacity and what is happening when they are having a late delivery, the belated supplier's delivery that can be due to defective parts, wrong parts, early delivery, or incomplete delivery, but mainly due to late delivery, as Thomas has explained us in the first stage, that this is the main problem that we can find in the industry environment. Of course, we have another kind of problems that could be the lost in transportation or administrative problems at customs when we are bringing parts from India or from China or from other countries that must be also taken into account. Regarding about the missing parts in stock run assembly, taking into account all the parts that delivered as A parts, the 30% of these parts, sometimes they have problems with late deliveries. In the case of B parts, in the 17% of the cases, they have some problem, and in the C parts, in the 24%. And regarding the problems with on deliveries, in 2011, they have some problems in some machines. Just an example of what happens in an industry. Here we have a linear guidance system. They sent an order to a customer. As you can see, the query date was done in February, and the final part didn't arrive until the 1st of October. I mean, 8 months. It's a lot. It's not affordable. I mean, it must be. You must correct this kind of problems. That's why Danawat also was introduced in the InTime project in order to avoid and to solve this kind of problems. Why? Because if they don't do that, they have loss of competitiveness, and they lose the confidence of their customers, because they lose their internal efficiency, because they can have some possible penalties, and due to they have to take a lot of reactive and proactive actions that finally they are it's a cost for them. So they must avoid it in order to be more competitive. Here we have some numbers about, okay, the main numbers of order lines that they have, they are on time. But there are some parts, B parts especially, that they have deviations that they must be improved. Here we have more detailed information. You can see that A parts is practically, we have no problem. In B parts is where we must focus. And in C parts, although it means that we could have some problems, if we see the deviation in days is not so much. And taking into account that usually customers or companies, they took some internal buffers in time and in stocks, for these C parts, they have no problems. So we were based in B parts. The reasons for this kind of problems, as Thomas has told us before, we have non-hierarchical production networks, which is where we have multiple and dynamic relationships. We have market power imbalance because we have some very powerful and very large suppliers where we don't have enough power to negotiate with them because our customers see us that they want a specific CNC, for example, so we must buy that. And in other case, we have very small suppliers where here we have the power, but we have low volume with them, so there is not too much to improve. Then we have the complexity of the machines. We have different models with a lot of active parts that must be managed. And if you have different projects at the same time, it means that we must deal with a lot of orders at the same time, and it could be a problem. Then we have the no feeling for necessity or urgency of in-time delivery, lack of time or lack of time or pressures that sometimes occurs in the companies, and lack of information transparency. I mean, the acknowledge of the supplier's real status at capacity. So the main objective with this project was to increase their competitiveness easily. They want to improve the delivery reliability ratio, which was the reduction of internal costs due to belated deliveries, and in this way they will have higher margin and profit, and to get more efficient management and organization. Going to the special use case that was carried out in Tanovat, we will see the full overall and the all steps and process that are given since the customers are in contact with Tanovat until the machine is delivered to the final customer. Here, this is a real case where in March of 2011, Tanovat received the request for a quotation for a centerless reading machine for a customer from automotive sector to mechanize some specific parts, like this tube, with some specific grinding specifications, and the offer that was done was around 600,000 euros for this machine. After some negotiation, they received the final order with these specifications. This machine, with the delivery date for October of 2011, and with some penalties in case they deliver the machine late. So, for them, it was very important to deliver and to work as best as possible. Now we are going to see, I'm going to quite quick with the different steps that they follow. Initially, they make an order acceptance meeting where they define order planning, all the technical issues, when the different parts must be sent, and then they start doing the different meetings in order to follow the project and know how it is. Engineering department, they start with the different drawings of the machines, doing them as we have seen. The machine is a standard, but some customization must be needed. So they start doing these modifications. they develop all the structure of the machines, where you can see the different elements that each module and group is composed by. Once they define all the structure, this structure is sent or transferred to the ERP in order to start defining, okay, we need to buy these parts, these ones we have in stock, so these ones, they are not necessary, or whatever. And now we will see a specific case with a ball bearing, which is supplied by two suppliers, and we'll see how they work with the InTime tools that have been developed in this project. Initially, the purchase department select the parts. They must define who are going to be the suppliers, but as we have said before, they try to use very specific and minimized suppliers, because they try to have a long-term relationship with them. So the purchase department, they have different steps, annually and monthly and daily, in order to negotiate and find who must be the best supplier. So we took this part, the ball bearing. They sent a request for quotation to the two suppliers selected, Egondo and Tecnomeca. Once the request for quotation was sent, after that they received the offer from these suppliers. So the next step was, okay, now I must select one of these, but which is the best one? Okay, maybe this one is cheaper or the other is one cheaper, but I must take in account, if they are late, which is going to be the cost that they are going to incur me. So here we can see, taking into account all the deliveries that they have with me during the previous year, which is their reliability. And if you see upstairs in the right side, you will see the average cost per order, that if this supplier is late with me, that going to incur me in this order. So in this case was 54. In the same way it was done with Tecnomeca, and if you see, in this case, if they are late, they are going to produce me more internal cost, 1,005 euros. So it means that for a price of 440 euros and the internal cost of 54 in the case of Egondo, in Tecnomeca we have a lot of a lot of costs, internal costs. Okay, in this case they are lucky because also the price of the part is higher in Tecnomeca, so the selection is quite easy. But if you see here in the right side, you will see that Egondo is a little bit, the delivery time of Egondo is a little bit higher than Tecnomeca. But finally, Tanovat in this case selected Egondo because they were more reliable and the internal costs were less. So via BI-MU.mpeg factory, they sent an order for this part, and finally they received the part. It was picked, they prepared the trolleys in order to be assembled in the machines, and finally the machine was set up and delivered to the customers on time. So if we see which have been the main exploitable issues that they have achieved during this project, they have been the financial assessment of impact-related deliveries, the reference model for procurement management. They have changed their mind that now, instead of just being focused in the price and the delivery time, they must take into account also the internal cost and how they must work. And the main benefits that they have got has been the new negotiation mechanism to improve competitiveness, the real knowledge of the impact of related deliveries, and then they have the new dashboards that they permit them to know which is the reliability of their suppliers with them and the overall network. Of course, they have, during this project, different kinds of problems also have been detected, because not always if the supplier is late it's due to the problem of the supplier. Sometimes it's because we haven't sent them all the required specifications in time, or customer hasn't tell us which is the necessary information. So we have detected also some other actions that must be improved, and I think Tanawatt nowadays is working in it. So here we can see the next step that Tanawatt is going to follow during the next months and years in these aspects. Thank you very much.
Thank you very much, Mark. We are just in time. So now we are coming to this part of the presentation you all have been waiting for, I guess. So we're gonna jump into the tool right now. We're gonna show you how the tool looks like, how the web-based tool looks like, and explain to you in a practical example how you can gain benefits out of the developed tools.
Okay, so just that you see that it's not just a video we mocked up. It's a real tool, it's web-based, and it's embedded into the BI-MU.mpeg platform. And I think we should start by just taking a look at the overview dashboard. Now you see there are some loading times, of course. So this is a dashboard for Pictionary suppliers now. And we see first overview of the complete purchases, so the complete order, number of orders, and on the right side we then see the product breakdown, what products we ordered at this supplier, and on the bottom we have the reliability history for the supplier. This is not only our orders, this is the orders from the network. So it means this is data you normally would not have with the ERP system. This is all, we collected this data using the BI-MU.mpeg platform, because every order data that is exchanged over this platform can be displayed here. And then, as in the video, perhaps we showed just a few highlights. We go back and then go to the performance dashboard. This was a dashboard which Anna, the procurement manager in the video, used to pre-select the suppliers for sending the request for quotations. Again, we want to order a cooling aggregate. It's at the bottom of the list. So we select the cooling aggregate, and then the analysis time frame, perhaps we select now one year, just for all year. This now is the whole time span, I think the recorded data from 2009. So you can see on the left hand side all available suppliers and a lead time breakdown. The breakdown is in first the time to quote, which means how long does the supplier take to send you the quote back after you send the request for quotation. Then the negotiation time means how long do you have to negotiate with the supplier to put the final order. And then the delivery time from order to delivery. As you can see, you can play with the dashboard, it's interactive. And on the right hand side, we have again all the available suppliers, and this now is the number of orders you have placed at the supplier. That you can see, it's basically your history. So saying, okay, at MT Supply, you have ordered a lot, so perhaps you will order there again. And from this dashboard, you can pre-select suppliers. You normally would select suppliers with the least lead time. So usually it would be Dumens, MT Supply, and Unair. And to these suppliers, you would send a request for quotation. And then, when we get the quotations back, everything inside the BI-MU.mpeg platform, you can see on top on top left, this is your data you send with the request for quotation, so your desired data, and then on the right you can compare it to the 3 quotations you got back from the suppliers. You get warned if there some required dates are exceeded, for example. So we see at the supplier Unair that he's not delivering in time, so he cannot deliver in time, and so therefore you would just disregard him because you need the product in time. And then you would have to select between or choose between the first and the second supplier, and there you can take a look at the reliability. As I said, the red curve is the reliability with your company, and the blue curve is the reliability in the network. So here now, as Thomas said before, you could really take a look how he's performing with you and how he's performing with the network. So perhaps we can also display the order count. The order count. You can also see the order count, just to see how many orders have been placed at the supplier and how many orders the delivery reliability has been computed. And you see that we have few orders, so the orange orders are with your company, the blue orders again with other companies. So there were a lot of orders in the network. And then you can switch back to the reliability and do your final decision. It will probably then be, because here were no orders and here were also no orders, and you see basically the reliability, the overall reliability of empty supply is the highest, and perhaps you would select this supplier for sending the final order. But then there's another dashboard. This is the negotiation dashboard, which gives you a very detailed look at this supplier. So now you have to select the product again, so the cooling aggregate. And the supplier you want to analyze. This is then empty supply, topmost. And the analysis time frame as before, for example, the last 2 years. Oh, there's a lot of calculation in the background on our server. If you're interested in the technical part, there's a data warehouse, a lot of SQL queries running on it. So now you can see here a summary of the delivery reliability and the lead time, just in a few numbers. Perhaps you can go with the mouse over it to see the tooltip. So we see, okay, the delivery reliability with the supply network is 87%, and then with my company, it's just 75%, so this would be an issue perhaps you would have to address in negotiating the order. And then we go to the lead time, we see, okay, lead time of the supply network is 52 days, with my company 53, this is not a big difference, so there we don't have to address this. And we can see in the lead time breakdown on the left side, we see there are no big deviations, there are a few deviations. Perhaps if you deactivate all the blue, red and green stuff. So you can filter out the deviations, where there have been deviations from the delivery date. So this is also with the network. So here you see there was a deviation in, I think it's December 2011, and then a deviation again in May 2012, and in, I would say, August, but you can zoom in there. Yeah, so one is in July, one is in May. So that means there are few deviations, but not much. And I think in general, we activate everything again. Yeah, he's a pretty stable supplier. And for the final negotiation, you can then use also the KPI breakdown, which gives you on the top, gives you a breakdown of the lead time again. And on the bottom, it's about reliability. And the good thing about this is it's everything in relation to the branch average, which means that every supplier who supplies this product you want is taken into account, and then it's put in percentage to the branch average. So if the percentage is below 100, means it's basically good. 100 is exactly the branch average, and above 100 is basically worse than the branch average. And here we see, as I said in the video before, the supplier is very reliable, but if he delivers late, he delivers a little more, so the deviation is more than the branch average. So you should address this and make sure that on your order he's really doing a reliable job. So this was the live presentation. Perhaps there are some questions. Thomas, you come to the stage.
So thank you very much, two of you. Yes, so we have some questions in the audience.
I want to know, is this tool ready if I want to use it tomorrow? Is it ready to be used?
Yeah, it is ready to be used. It's necessary that you connect your ERP system to collect the data without any hazard, because otherwise you have to put it in all the time and it's a little bit too much work. So if you connect your ERP system and the ERP system of the suppliers, it's no problem. You can actually at once collect all the data and visualize the data like we see it here.
So in the frame of the project, we did a complete proof of concept of the whole data supply chain, from my own factory to our server to the charts. So it's proof of concept is completely there.
Further questions? We have an interesting guy.
What is the price of the tool? How much does it cost?
At the moment, for the API communication, it's 60 euros a month, and per message you are sending, it's 20 cents. And the collection on the tool is, at the moment it's for free, but I think we will change this at the end of the year. But we don't have a price yet, so.
Okay, some more questions? Nobody? So, thank you very much. If you maybe have some questions later on, we have an InTime booth which is standing
in this hall 834.
834? Okay, 834. We're going to have our computers over there. If you want to have a closer look to the tool, if you want to have another customized presentation, maybe you're interested in some further issues, maybe talking about the data warehouse or whatever. If you're interested, you're of course invited. I think we even have candies, right? Perfect. So, thank you very much for the attention and enjoy the people. Bye-bye.